Well, hello everyone, and welcome to the new year, and Happy New Year as well. You're welcome to our very first webinar, set online webinar for the year. We are excited to have you here with us, and we appreciate you taking the time to join us from different parts of the world. Today we'll be having a speaker in the person of Ameshe Bodhi, and she obtained her PhD from the Rhodes University in South Africa, and she went on to do her master's in Hungary. She's currently so she was a postdoctoral researcher at the Evolutionary Science Institute in Johannesburg, and subsequently lectured in geology at Rhodes University until 2011. Her current research is in clastic sedimentology and focuses on quantifying biogeographic and paleoecological processes, primarily examining the Paleozoic and Mesozoic depositional record of Southern Africa. As usual, I would employ each and everyone to visit the SEST Online website and YouTube channel to access most of the all the SET Online webinars that have been organized in the past. SET Online does well to also organize teaching and have other resources that would also be beneficial. So during our presentation today, the chat will be closed and it will be opened towards the end of the presentation for questions. When asking questions, we would ask that you please include your name and where you are asking the questions from, so that we can do well to also mention these in the chat. I'll read the questions later after the presentations to our speaker to have her respond to all your questions. So without further ado, I would hand over the mic to our speaker, MSF, and take it away. Thank you.
Thank you very much. I'm just sharing my screen. All right. Can you see my screen?
Yes.
I hope
Can you
can.
switch to presentation
Lovely.
mode? Can you switch the display?
Oh, you're seeing the you're seeing my presenter mode, not,
Yes,
I
the
mean, you're seeing the
presenter.
presenter notes, not the oh, okay. In that case, I apologize, but we'll have to quickly just do. Right. How about now?
Yes, that's
Can you
perfect.
see?
Thank you.
Lovely.
Yeah.
Thank you very
Thank you.
much. That's great. All right. In that case, I'll just thank you so much, Isaac, for that introduction. Indeed, I work in South Africa. I'm here since my PhD, which I finished in 2001. And after 2011, I moved over to Cape Town. So I work here. I work at the University of Cape Town, which is in the southwesternmost point of Africa. And I hope that you and the audience will come and visit us. We're hosting a major conference at the University of Cape Town in November 2026. It will be on paleontology, but there will be lots of paleo sessions. I mean, there will be lots of sessions linked to sedimentology. I'm originally from Hungary, as that probably became apparent from your introduction. Indeed, I did my MSc in Hungary. So once again, thank you very much for attending this webinar, and Happy New Year to all of you, since this is the very first seminar of the year, coming to you, like I said, from sunny Cape Town, because down here right now it's full summer. Right, so my talk is going to focus on a global event that became um, in the focus of researchers' investigation in the past, well, about 2 decades. And this is a late climatic shift when we had an increased humidity and rainfall. It's also referred to as the Carnian Pluvial episode, but actually the correct term is or a Carnian Pluvial Event, but the actual correct term is what I have up here, episode, because it wasn't just an event, it was a series of events when major humidity events happened with significant rainfall, and these physical changes in at the Earth's surface triggered obviously landscape changes and major biotic changes too. One of the very fairly recent and very good summaries of the Carnian Pluvial episode is by Bernardi et al. In 2018. And I'm showing you here the highlights of that paper, which shows how this major terrestrial ecosystem change impacted life on land. But of course, for those of you who work with marine sediments, a lot of rain on land causes higher rates of sedimentation, broadly speaking. So that will also be manifesting itself in changes in the marine rock record. So on land in the Carnian, which is about 237 to about 227 million years ago, roughly about 10 million years, in the Carnian, the dominant tetrapod life was at the beginning very different to what ended up being towards the end of the Carnian. So we're seeing a change from a crocodilomorph dominated biota to a dinosaur dominated biota. So it's an event that apparently can be tracked across the globe, in some places better, in other places not so clearly, but nonetheless, this change in biota seems to go hand in hand with major expansion of freshwater ecosystems that have, as I mentioned, reshaped especially the continental systems, continental ecosystems, but also the marine ones. What caused this major humid significant rainfall phase is still matter of investigation. The event or events have been linked to a large igneous province in the northwestern part of Canada, just north of the Vancouver Island in Canada and Alaska. As it happened with many other major biotic changes and that led to, in other parts of the geological timescale, to mass extinction events. There too, we have large igneous provinces as a triggering reason. But that is still being investigated. It's a lot more work that needs to be done. And that is why any record, any terrestrial record from this period of time from anywhere in the world is actually quite important. And this is how we're going to take our journey back in time, okay, to the late Triassic, but all the way down to Southern Africa, because here we have a sedimentary unit, a clastic sedimentary unit that has been identified as being Carnian in age, and it has the potential to shed light and therefore refined what happened before, during, and also after the Carnian Pluvial event. So my talk obviously is going to be focusing on Southern Africa, and in order to put the unit, this Carnian unit, into a better context, I thought I'm going to share with you a little bit about the geological background of the region at this time. So we are now looking at a map of southern Pangaea, which at the time was made up by the southern hemisphere continents, is also referred to as Gondwana, although by this time, by the Carnian, Gondwana was united with the other continents of the planet, forming Pangaea as the supercontinent, and that's why I'm showing you this global reconstruction map here. But if we focus on Gondwana, particularly southern Gondwana, the two main geological components that we need to note here are the so-called pan-Gondwanian thrust fault belt, and behind that, further to the north, a foreland basin system that stretched across the southern margin of Gondwana. This foreland basin system and the thrust fault belt were generated as a consequence of the subduction underneath the southern margin of Gondwana, and that's marked with this serrated line over here. The Karoo itself, where our Carnian unit is found, was of course part of the foreland basin system. To the west of us, we had the Southern American portion of the foreland basin system in the Parana Basin these days, and then to the east, we had the Antarctic foreland basin portion, which is referred to as the Beacon Basin, and so on and on. So this is a continuous foreland/thrust fault belt system that existed over up to about 8,000 kilometers. Here is a scale that shows you the aerial extent of the foreland basin system along the southern margin of Gondwana. So it was really a large dish, an asymmetrical, typical foreland basin system, an asymmetrical dish that collected the sediments from the beginning of the subduction time, which is more or less at the end of the Carboniferous. So what I'm showing you here is the geological map of the main Karoo Basin. The countries that make up Southern Africa are also shown here. And of course, the Karoo stretches over the boundaries of South Africa. But the main basin, the best preserved basin, the main Karoo Basin, is found in South Africa. And to the south of it, we still have the remnants of our portion of the Pan-Gondwanian thrust fault belt, which is the Cape Fault Belt. And then if you look at the colors of this geological map, they are indicating the various units that fill up this foreland basin portion from the Carboniferous all the way to the Jurassic. So that's the Carboniferous was the start of this foreland basin system, and the early Jurassic was when the foreland basin system came to an end, most likely because subduction terminated to the south of Gondwana. So what we have in the main Karoo Basin are 5 major units, taking up about 120 million years of sedimentation. And it's represented by about, in its thickest part, in the most continuous part, by about 6 kilometers of sediments. Of course, this is not continuous sedimentation, but it's fairly continuous sedimentation. And except for the first 2 units, the Permo-Carboniferous units, most of it is actually continental sediments. Now, in this 120 million year worth of sediments, we have a record of changing climates, changing biota, and of course, we also capture the record of mass extinction events as they happened through the late Paleozoic and early Mesozoic. The unit that I'm talking about, the Molteno Formation, is marked here. This is, as I said, a late Triassic unit, Carnian in age. And it formed, of course, at the time when there was no longer any marine sedimentation in the system. In fact, marine sedimentation ceased, as I said, in the early Permian, in the earliest Permian. So all these rocks that you see marked here are in fact continental rocks. And most interestingly, both the Permian and the Triassic part of the succession, as well as the overlying unit, are red beds. So we have a strong aridification trend from the early Permian all the way to the earliest Jurassic. The Clarence Formation, for example, is a wet aeolian system. The anomaly here is this Molteno Formation. This is the only non-red bed succession over almost about 80 million years in the history of the main Karoo Basin. And that is something that I will be talking about in more detail. So once again, this is the map and the stratigraphic section that I've just explained. What I have here is the outcrop area within the main Karoo Basin of the Upper Karoo. The Molteno is the oldest unit of the Upper Karoo. So this is a bit of local stratigraphy, but I think it's important for you to hear it in order to see how large the outcrop area is, to have a feel for where our data is coming from. So in terms of the size, this area is about 400 kilometers long in a southwest northeast direction. You see it forms this rectangular shape, outcrop pattern. And what you also need to know is that as we go from the Molteno towards the center of Lesotho, in other words, the Drakensberg group rocks, the topography becomes higher and higher. So what we see here based on this map, of course, is that we have a flat attitude to our beds. So it is an undeformed section. And the reason for that is that this part of the foreland basin was in the distal portion of the system. So it did not experience folding. And also it formed towards the final stages of that foreland basin development. So we don't really have a lot of folds or even folds, but we have quite a lot of dikes and sills that prevent making thorough observations in the Upper Karoo. So without further ado, here is a little bit more about the Molteno Formation, which contains the data that I want to talk about. And the three main points that I want to discuss are the age, the type of rocks that we have, and also the paleontological record of the Molteno Formation. I'm going to go in reverse order, and I hope it will make sense towards the end why I chose to do that. So first and foremost, if we turn our attention to the paleontological record, the Molteno Formation stands out as one of the world's most well-endowed, richly fossiliferous sedimentary units from this period. And it's dominated by plants, by a fern type called Dicroidium, the dominant flora, macroflora in the late Triassic. And in addition to that, we also have the first record of amber. It was discovered in Lesotho, which is a landlocked country within Southern Africa, still part of the Upper Karoo. And then we have a plethora of insect fossils, fish body fossil impressions, and a variety of insect-plant interaction, which would be considered trace fossil, together with other invertebrate trace fossils. Now, when it comes to vertebrates, I will keep that for the second part of the talk. It will be kind of one of the highlights of this presentation. So when it comes to plants, really the 200 plant species that make up the plant record, the macro plant record of the Molteno Formation gave so much data to our paleobotanist colleagues that especially two of them, Heidi and John Anderson, have been publishing about the macroflora since the 1970s, several monographs, and they are still busy with other books that are based on this plant fossil material. Very diverse, beautifully preserved, and contains a lot of evidence that is extremely useful when it comes to reconstructing paleoenvironments. So here are a few examples. These are plant fossils, leaf fossil impressions, whereas this one here is a petrified tree trunk. The scale bar here is 10 centimeters. The same scale bar is shown over here next to a in situ tree trunk with roots, shallow, almost semi-horizontal roots that go out sideways. So associated with these trees, we have a whole variety of leaf impressions. And here are a few more examples of dicradium and other plant fossils that make up this truly outstanding assemblage of plant macrofossil record in this part of the succession. So I think that's enough for now for about the paleontology. I'll pivot back to that when it comes to the footprints. I now want to focus a little bit on what are the rocks that contain these plant fossils and other fossils. And these are coal-bearing sedimentary rocks. The Molteno is dominated by quartz-rich feldspathik sandstones. These form upward fining successions that overall are organized in major large-scale upward coarsening successions. That's why I have both triangles pointing upwards and downwards to show you the hierarchy of these various multi-story and laterally extensive sandstone bodies that dominate the Molteno Formation. In addition to that, we also have carbonaceous mudstones with some coal seams. In this illustration that I'm showing up here, this is a road cut near the town of Dordrecht. That's a person there for scale. We have the carbonaceous mudstones at the base, and then a beautifully exposed multi-story sandstone unit above that. Here is a interpretation of this outcrop. So as you can see, there are several channel-shaped bodies that crosscut. These numbers that I am pointing out on this overlay are actually the order of the relative order of the channels as they formed and incised into one another, forming these multi-story channel bodies that are laterally quite extensive. Here is another example. This is a road cut not far from the town of Stekspruit, and that is in the Eastern Cape of South Africa. And here too, if you engage with both the photograph and the overlay, we have laterally extensive sandstone bodies that are dominated by crossbeds. That's one of the most common sedimentary structures in the Molteno Formation. And these sedimentary units in most of the Molteno Formation form downward accreting bodies that show upward fining, but laterally they stacked in a way that is characteristic of braided or low sinuosity river systems. So as I said, the most common sedimentary structure is crossbeds, which is abbreviated here with the classical fascist code of ST and SP. I'm showing you a few examples. This photograph that is on the left-hand side is taken from this part of the outcrop, but there are lots and lots of examples. Virtually, as I said, that's the most common thing that you come across in Molteno outcrops in various shapes and forms, be that tabular or trough crossbeds. luckily we stopped classifying them any further in more recent years, but probably the Molteno would have been a good candidate for the various other types of crossbeds that were favored in the 60s and early 70s. So yes, crossbedding dominates, but in addition to that, what also dominates the clastic, coarser grain clastic units is a variety of soft sediment deformation features, which range from recumbent folds, the ones I'm showing you over here, to various water escape structures. This is a water escape structure that disrupted the entire package of this otherwise low angle cross-bedded coarse grained sandstone. The scale bar here is about 15 centimeters. So that's a very common additional feature in these sandstone bodies. And then not very common, but present are lovely little raindrop impressions that form these circular pits with elevated rims, which form as a consequence of raindrops falling, impacting on soft sediment surfaces. Desiccation cracks are literally non-existent. Very, very seldom we come across. But all other features indicating high energy fluvial processes in low sinuosity river systems are highly abundant, and the sedimentology of this unit has been very well documented in the late 70s, early 80s. We are just trying to bring that material to a more modern, more up-to-date framework, but the basics have been covered very well and in great detail by especially our late colleague Brian Turner. So if you were not convinced by my Carnian raindrop impressions, I thought I'll show you a modern equivalent. So on the left-hand side, we have the Molteno one that formed about 235 million years ago. And then on the right-hand one, map views of a raindrop impacted surface across some asymmetrical mud-draped ripple marks. They are well developed on this side of the photograph. So yeah, they fairly abundant and rather interesting, since it is believed that the Carnian was a segment of our geological time when rain was quite abundant, anomalously abundant. Right, so going back to the list that I want to present about the Molteno formation, we talked about the paleontology, we talked a little bit about the sedimentary rocks, the coal-bearing sedimentary rocks, and then, of course, the age. And for both of, for determining the age, these two elements, the paleobotany and the sedimentology, seems to play an important role, because the age of the unit was first determined from sporomorphs, and that is from the early 80s, late 70s, early 80s, by the Andersons. And then fairly recently, this is not yet published data, we have gathered detrital-zircons that yielded a late Triassic age, scattering within the Carnian, some of them indicating ages of Norian for the uppermost part of the Molteno formation. So this stratigraphic column is already representative of the new but not yet published record. So both these aspects, the paleontology and the sedimentology, are important in reconstructing the paleoenvironment for the Molteno formation. And when it comes to the plants, they were probably providing a more refined data set, because with the help of the plants, several habitats, several peat-forming habitats were reconstructed by our colleagues, in addition to the overall picture that was indicating already from the late 70s a braided fluvial system that drained towards north from the Cape Fold Belt. And like I said, the plants helped us refine that paleoenvironmental reconstruction. So these numbers that are on this block diagram are referring to these various peat-forming habitats from riparian forest all the way to marshes and thickets and various other primary habitats within the Molteno paleoenvironment. So with that said, what about the animals? Because we have all these wonderful habitats. Well, in addition to plants, surely there were animals that lived in them. And yes, as I mentioned, we have record of insects and fish body fossils, but there are absolutely no bones preserved in the Molteno Formation. To date, there have been no record of any fossilized bone in any part of the outcrop area, be that in South Africa or in Lesotho or in any other parts of Southern Africa where this unit is exposed. So that's an enigma, but it's not necessarily huge enigma because it comes down to the geochemistry of the post-depositional processes. Most likely the bones were there, but they got dissolved. It's a taphonomic filter that we are actually seeing. And we know that partly from the fact that the oldest dinosaur fossil record from Southern Africa, from Southern Gondwana, comes from the Molteno Formation. It is two sites that citizens, or citizen scientists rather, have reported already from the 1920s. They have, of course, not identified to species level what these footprints were. They were loosely called dinosaur tracks. But indeed, these tracks clearly show the presence at the time of large-bodied animals. Now, what we did, we have re-investigated the known sites, the ones that have been reported on and those ones that have not been reported on, but were known by the citizen scientists, farmers who live in these regions. So we revisited the various sites and documented and redocumented these footprint sites. And what we found is a huge diversity of not only tridactyl footprints, which were previously referred to as dinosaur footprints, but a whole lot of other types of animal footprints and markings, as you will see it from the slides. So our methods are standard ichnological methods, very strongly rooted in plastic sedimentology and clastic field sedimentology. So what we do when we apply standard ichnology, we find the sites and then we start brushing and brooming and doing more brushing and brooming. And probably this is why the highest, most expensive budget on my research items or on my research budget is actually brooms and brushes, because we go through a huge amount of them during every trip. It takes quite a lot of effort to uncover the modern sediments that usually bury the tracks, but with persistence and with a structured approach. Here I'm showing my other half and my little goal some 5 years ago. So with a lot of effort, indeed, the tracks can be uncovered and reveal themselves, and not just the tracks, but also the associated sedimentary structures. In this case, if you look carefully here, I'll show this in a close-up image later on, we have some well-preserved desiccation cracks and also invertebrate trace fossils. So These were the traditional methods. When it comes to the modern methods, we also employ them. These are very simple, routinely performed standard ecological methods these days. It involves taking photographs, overlapping photographs of these tracking surfaces, which we then combine and generate false color depth maps that will reveal the subtle footprints, even the most subtle one, much better than what you could see with the naked eye. A problem with flat surfaces is, of course, the sun, especially in Southern Africa, where in summertime the sun can be rather harsh and bright. So we can only really see the tracks with naked eye in their full glory early or very late in the day at sunrise or sunset. And that is difficult to well, aim for, but also to cover most of our fieldwork in those few precious hours. We try to do our best, but often locating a site takes half of the day. So by the time we get to the site, what we see with the naked eye is very limited, but thankfully we have photogrammetry that helps us view even the most subtle footprints. Right, so this surface here is the one that my daughter, other half, and myself cleaned, and as you can see, it's covered mostly by tridactyl footprints. I highlighted here 3 of them. Hopefully by highlighting them, you can identify many more on your own. This is a highly high traffic area. It was very difficult to identify on this surface any trackways, but other surfaces were kinder to us, and we could do that with much more ease. In addition to tridactyl tracks, of course, we have a variety of various sedimentary structures, from invertebrate traces. Those are the ones that are pointed out with the arrows over here. Those are the zigzag lines, but not a regular zigzag line, because, for example, this fairly more regular sinuous line is actually a tail drag mark, and we know that because it is associated with footprints on either side. Right here, I'm highlighting one of the trackways on this other surface, and then over here, a high traffic area again, where you can make out quite a number of footprints going in both directions. So there are many overlapping trackways in this zone over here. Most of these that I'm showing on this slide are in fact made by the same tridactyl track maker animal. In addition to that, we also have drag marks. Not all of them are tail drag marks, and the reason for that is that many of these, for example, this very prominent one, are not associated with any footprints. So even though we looked very carefully, we couldn't find pairs of footprints associated with literally either of these. Often these drag marks also crosscut, and they vary in size and width. So most likely, some of these at least were generated by an object that was dragged in this shallow water environment. Here is another surface. I'm showing you again sinuous lines, which are in this case a tail drag mark, because if you look carefully, what you will see is that there are footprints associated with this linear feature on both sides. And if you check carefully, you will also see that the footprint forms kind of like a comma, like a point and then a drag mark. And that's exactly what it is. These are the toe marks, whereas these curved lines are the toe drag marks. So these are digital traces, the traces of the toes and fingers of the animal that has been dragging and walking in a reptile kind of manner across the surface. The direction of movement was from top to bottom, and we know that from the direction that is shown by the drag mark itself. I have reconstructed here some of the better preserved ones, indicating with this arrow the direction of movement of the track maker animal. So this one, this animal, this track maker animal was nothing like a dinosaur. This was most likely an amphibian, a temnospondyle amphibian creature that lived both on land and in the shallow water ponds that dominated the Molteno Formation. Another footprint set is shown over here. This is one of the most well-preserved ones. So this is not a tridactyl, but rather a tetradactyl animal that left behind this trackway. This is the enlarged area of the one that is marked in yellow. So as you can see, the four toes are well preserved, and then intermittently we seem to pick up a trail drag mark, but it looks like this animal wasn't constantly dragging its tail. It was just letting it down time to time, probably depending on the speed of the locomotion. So that was the beauty. And then here is the beast. Probably if you look at this paleo surface, this trekking surface, you would be wondering, what is that I'm seeing here? Well, in addition to this big crack, there are footprints. There is one over there. If you squint hard, there are two over here, but I'll help you by showing the processed image. These are ortho photographs. And on this, I have marked out the actual footprints. This area is enlarged down here, showing you the two footprints that are overlapping. So most likely the animal that walked from left to right was overprinted. It's one of its tracks was overprinted by another animal. It's not likely that this is a hand impression, because it's very similar in dimensions, and it's a solo one. So it just like several others on this surface, and this configuration only occurs once. So that is not enough reason to assume that this second track is a hand impression. Right, so if we zoom in, this track here shows us more anatomical details. These are the pad impressions of the animal, and of course allows us to measure the length of these digits. And from the size of the track, and also from the size of the steps, of the consecutive steps, or tracks rather, we can actually figure out the speed of the locomotion. So those are very basic calculations that we usually do in Ichnology in order to reconstruct not only the body dimensions of the track maker animal, but also the way it behaved, whether it was walking or running or trotting and so forth. Here is another example of a large beast. So it's a footprint that is very poorly preserved. In fact, two footprints, which is in Ichnology considered already a trackway, because from this we can figure out those parameters that I've just mentioned. And if you squint very hard, you will be able to make out the four toes. So this shape with the four toes is in fact a poor representation of animals that started to dominate this part of the geological record. And these are the earliest dinosaurs. These are what paleontologists refer to as basal sauropodomorphs. So when we pull all of this together, what becomes apparent is that we have a diverse assemblage of bi- and quadrupedal animals. These track makers were not only dinosaurs, but they were amphibious tetrapods. A lot of them were, of course, the classical animal type at this time. In other words, pseudosuchians. And also some of them were made by dinosaurs. But by far, it looks like the record is dominated by pseudosuchians, which are a type of crocodilomorph, an ancestor of modern crocodiles. So what does all of this tell us? Well, the ichnology without the sedimentology in our case wouldn't work, because sedimentology, and particularly field sedimentology, help us put the findings, the trace fossils, in their stratigraphic, in their paleoenvironmental context. Remember, these are clastic coarse-grained sandstones in which these footprints are found. So plant fossils are not preserved there. We are fully reliant on the sedimentological record to work out the sites, the paleoenvironments in which the animals actually walked over. And then, of course, we combine that with the plant fossil record and everything we can put our hands on. But what I'm trying to emphasize here is that in order to meaningfully engage with the tracks and extract the messages that are in these vertebrate tracks, we very heavily rely on clastic sedimentology. And once we do that, there is no question that the record has been recently expanded, both in terms of diversity and also in terms of insights into how the Carnian Pluvial period or episode unfolded in this southern part of Gondwana. So it does help us with understanding better how come that at this time we have an anomalous rock record, because remember, before the Molteno and after the Molteno, the environment was semi-arid, dominated. The rock record is dominated by red beds, in fact, to some degree, semi-desert, desert conditions. We have here this anomaly, and this anomaly happens at a very critical time, at the dawn of the dinosaurs. So it helps us refine how that turnover from a synapsid-dominated biota to a dinosaur-dominated biota, from a red bed system into this coal-bearing system, has taken place. But of course, it also helps us feed data into the global picture to understand across Gondwana and across Pangaea, the dynamics of this major upheaval in the geological record, be that looking at it from sedimentological or paleontological point of view. The details obviously still need to be worked out. We still need to understand the triggering factors, but at this stage, we are glad that we can contribute to this emerging picture, refining this emerging picture that helps us better reconstruct the paleoclimate, the paleoecosystems during this time of the geological past. So all in all, the abundance and diversity of the tracks underscore the importance of field-based sedimentological work combined with robust ecology. It also helps us investigate both locally and globally the late Triassic ecosystem, and understand, hopefully with time, how the Carnian Pluvial Event came about and what ramification it had for life on planet Earth. So it will help us reconstruct the paleogeology, but also improve paleoclimatic, paleoecological, and also the biostratigraphic investigations as we go forward in the future. And with that, I thank you very much for your attention. And I also thank my sponsor, Genus, which is a ring-fenced funding agency by the National Research Foundation of South Africa, that is primarily supporting paleontological and associated work, such as ours, field-based sedimentology, stratigraphy, and Ichnology. So thank you very much for listening.
Thank you very much, Emerson, for the presentation. just a reminder, the chat is open for all your questions. And also we have some relevant papers for today's presentation also posted in the chat. So please do well to check them out. Again, thank you very much, Emerson. I just have a quick question. The drag marks that you highlighted in one of the presentations, you mentioned there was no relationship with it with the footprints, as in there weren't any footprints that could actually be related to those drag marks. Could you speak a bit more to it? Is there any like modern, yes, this one,
Yes,
those drugs. Are there any
yes.
modern examples to this, or what do you really think could have led to those drugs?
Thank you. Thank you for the question. So, well, first and foremost, obviously, what we do is try to document it in the field and also in um, using photogrammetry and try to look at how it shows up in terms of depth, changes along this groove, what are the associated features that we can observe. For example, expulsion marks, or like I said, whether we find any tracks going parallel to these drag marks. I'm going to point out a few of them here. So there is one over there. I'm not sure if you can see it. This is the most prominent one. And then there is one that cross-cuts the main one at an oblique angle over here. And then there are several other ones that are not in the illustration. So this is the big one that I showed you. And if you look here, it's very clear that the sediment was as soft as it was when the footprints, or might have even been softer, or this dragging object has actually created a stronger displacement of the sediment. So all of these features can be seen in association with tail drag marks of animals that live in shallow water environments. But in the moment, we don't have any tracks going parallel or in association with these lines. It's very hard to argue that these are in fact trail drag marks. So what I'm thinking is maybe we had for example, a stick, like in this modern river, you see there is a stick over here, that a stick was dragged on the surface of the riverbed. It's just that, you know, when you find them in parallel, like the way they run in parallel, then it's a bit difficult to imagine that 2 or 3 sticks were dragged parallel to one another, more or less simultaneously. One fact remains, the paleo currents in this area seem to run exactly in this direction, from bottom to top. In other words, you know, that would be parallel. The drag mark would be running parallel to the paleo current. So that potentially could be another reason to say that this is an abiotic structure rather than a biotic structure. But yes, tail drag marks' key feature is that they should have footprints running along their side. So without that, assigning this to tail drag marks is a bit over ambitious, and we don't like stretching our data that far. We have enough.
Okay, all right. Thank you very much. We have a question from Stephen in Derby, the UK. So Stephen wants to know, do modern crocodilians SP produce tail drag marks akin to those that you mentioned?
Some of them, yes, they even produce belly drag marks. So what we can say for sure that our tail mark that is associated with the footprints that show digital traces, digital drag mark traces, was likely an animal that wasn't dragging its belly. It was only dragging its tail. So it was raised above the sediment surface. But yes, modern amphibious animals um, do drag their tails, and some of them even drag their body. Yeah.
Okay. So Stephen also says, thanks for the fabulous, beautifully illustrated presentation. We also have a question from Stefan Boden in Aarhus in Denmark. Pardon me if I didn't get the name correctly. So Stefan says, thanks for the nice talk and great field pictures. How accurate is the chronostratigraphy of the Molteno formation? That is, how can you be sure that the CPE is preserved in it?
Okay. Thank you for that question. So there are two lines of evidence. One comes from the plant fossils, um, uh, from biostratigraphic correlations. I cannot vouch for how robust they are because I'm not a paleobotanist, but that's what has been um, identified for the Molteno formation. But then our own work, which is based on detrital zircons. So we extracted detrital zircons from various sites, especially the sites associated with these um, track sites. And when we analyzed them for their uranium, thorium, lead isotopes, so based on radioisotopic measurements, the data showing that the maximum depositional age for the Molteno formation ranges from about 137 to about 220. So that range gives us an idea of it having formed more or less during the Carboniferous, I'm sorry, during the Carnian. Um, and in addition to that, we have dates, robust dates from the overlying units. Um, these are again detrital zircons, but some of those come from ash beds. And then as we go higher in the stratigraphy, we have evidence for um, ages from the basalts that are early Jurassic. Now going below the Molteno formation, again, the ages are constrained both with radioisotopic ages, but also with paleontology. And for those rocks, for the pre-Molteno rocks, which we refer to as the Beaufort group, the ages are mostly the biostratigraphy is based on tetrapods, various synapsids, what we used to call not long ago, the evolution of mammal-like reptiles gives a very good control with the radioisotopic ages for how old those units are. So we have ages both above, below, and also now we already have ages for the Molteno formation. So it does look like it's Carnian, but where exactly within the Carnian, that will be very difficult to answer because so far we haven't found pristine ash beds. All of these detrital zircons that we have analyzed are reworked from sandstones. So they're not primary ash deposits.
All right, thank you. There's also another question from Fiona in Bristol. Fiona says, I was also curious about the long straight drag lines. Any chance they could be a result of perhaps drags marks from fallen trees being blown across the shallow water environment? I guess this is what you spoke to earlier. So she also
Yeah,
says,
yeah.
super illustrations. Thanks for the fascinating talk. Thanks. Sorry.
Thank you, Fiona. Yes, I do think so. I mean, it's a little bit, super parallel, and it's like not very wide. This is the measuring tape, so it's about maximum 5 centimeter wide. And we have these two that run super parallel. They're not very different in size, although we also have this one here. I showed it in another illustration that is cross-cutting the long one. So yeah, I think it must be a solid object, like tree trunk, I mean tree branches, twigs. Yeah, we don't have evidence to say that they are uh, drag marks of
Yeah,
tails.
she
Yeah.
did. All right, so Fiona also did give a follow-up that parallel drags marks surely would be how you expect if a falling tree is dragged along. So
Yes,
I think
yes,
that
yes,
was
yes, yes.
yeah. So we have a question from Duana Golden in Colorado.
Oh,
So
wow.
Duana says, Emersha, thank you for the excellent lecture. I'm wondering what are the characteristic features of rain imprints?
Oh, okay. I'm so glad for that question. Lovely sedimentology question. You know, at my heart, I'm a sedimentologist. So let me go back to that. Apologies for the um, reversing so rapidly. But yes, so this is the illustration from the Molteno of the Carnian, well, more or less 235 million year old Molteno um, rain impressions, raindrop impressions. So as you can see, they circular features. So these are two different slabs. This is a finer grain. This is a slightly coarser grained, silty mudstone. And all of them have more or less the same size. So the scale bar here is my usual scale bar that I use in the field. So those markings are in centimeters. So that helps you to see the size, but also it helps you to see that more or less they are of the same size and very much comparable to modern raindrops. But you know, I mean, even raindrops can vary in size depending on how strong the rain is falling, how whether we have a subtropical rain or a quiet, drawn out cold front associated rain. So the rain, the crater diameter might be variable, but that's not necessarily a problem. The overall feature is the one that we need to concentrate on, and these are, like I said, little pits, circular pits, like little craters that have a rim associated with them when they are well preserved, and that results from the raindrop impacting on the soft sediment surface and leaving behind these shallow craters.
All right, thank you.
And these are modern examples, right? It's like from a field area, um, field work that we did last November.
Okay, all right. So Stephen from Bangor is back on the intriguing drag marks.
Oh,
He's
thank you.
wondering, he's wondering, have you spoken to Jacob Bass? He's worked on generating drag marks in the subaqueous, in the flumes, and has some really great insight into diagnostic sedimentary features that may help you link them to a mode of formation. I
Yes,
guess,
I haven't, but I would like to reach out to him. Um, that's a very good suggestion because I would really love some input on this. What I forgot to point out, and hopefully by now you have figured it out, that this is the surface, but in the middle here is the photogrammetric, the depth map of that portion of the surface. So this green mark here is the actual groove, and these are footprints. But as you can see, the footprints, as I mentioned before, they are randomly occurring. They don't follow this line. They are all over the shore. So we can't make that interpretation. But as of what made it, and yes, this depth map also quite nicely shows that the depth of the trough, that is the actual drag mark, is fairly consistent. Now and then is better impressed, but overall the depth is constant along the length of the feature.
yeah.
Mm.
All right. So, Ross Campbell from Kingston, Canada also says, what a wonderful talk. Thank you, MSA. I like the combination of detailed, low-tech, painstaking work with chalk and brooms and the digital enhancement. What is the potential link between a wet period and the rise of the dinosaurs?
All right. Thank you for those comments. So we see, I'll go back to the slide where just a second. I'll go back to the slide that shows how the composition of megafauna changed over time. And this is the work that was done by international colleagues. So that I'm referring to this chart here. So it shows the distribution of the various ichnotaxa, but also the track maker assemblages. So this part of the slide is referring to footprints, and this part of the illustration, rather, refers to the actual track maker animals. So this part of the chart is based on body fossils. This one is based on trace fossils. And what we see here on the climate reconstruction, this comes from the rock record, among others from sedimentological work that was done across the globe. So the summary chart shows us that prior to the Carnian, the climate was fairly arid and was dominated by these so-called, well, pseudosuchians, which are the ancestors of dinosaurs. Right in the middle of the Carnian, we have a changeover in the fauna, both ichnofauna and body fossil fauna, when we see the appearance of both the dinosauromorph. These are still creatures that look like dinosaurs, but they're not yet dinosaurs. That's why the morph word is there. And then this is actually the origin of dinosaurs. And that's why we refer to the Carnian as the dawn of the dinosaurs, because prior to this, we don't have any body or trace fossil record that would be indicative of dinosaurs. Now, how this change happened, how did the dinosaur, what prepared the dinosaurs to take over? That's a $1 million question. There are ideas around it, but obviously these are just ideas. So during a wet period of like this, we are reconstructing it for the Carnian, potentially there were a lot more wetter, marshy, swampy conditions that gave way to the dinosauromorphs, which then squeezed out in a way the pseudosuchians, the crocodilomorphs that existed and dominated the biota prior to that. And that squeezing out opened up the niche later on for dinosaurs. So obviously these are large-scale macroevolutionary ideas that paleontologist colleagues are investigating, and the ichnofossil record helps with that. For example, our work shows that indeed in Southern Africa too, the oldest surely dinosaur footprints are from this part of the succession, from the Carnian. But how exactly that replacement of the biota happened is something that is actively investigated. It's always a function of external factors such as changes in the climate, changes in the atmosphere due to large igneous provinces. And this is why working in multidisciplinary teams is very important, because we are able to contribute different ideas, different perspectives to these very large questions and difficult questions, complex questions, in order to reveal what happened in our geological past.
All right, thank you. We also have another question from Maurice Tucker. Maurice says, fascinating talk, thanks. And are there any large burrows in the Molteno? That is, are there fewer large vent burrows than in the Beaufort?
Yes, we don't have burrows. We have not found, let me correct myself there, we have not yet found any large vertebrate burrows in the Molteno. We have large vertebrate burrows below in the Triassic and also in the Permian portion of the Beaufort group. I myself documented quite a few of them. And we also have burrows that I myself documented from the overlying late Triassic, early Jurassic red bed successions. And maybe, just maybe, the lack of burrows is actually an indication of the fact that we have a much wetter environment. Animals burrow for various reasons. One of them is to take shelter from the heat of the sun. So if the climate wasn't that arid, um, maybe they were not forced to take uh, refuge underground. So vertebrate burrows are usually associated with sedimentary rock units that formed under more arid conditions. Invertebrate traces, they obviously are all over the show, but vertebrate ones are, at least in the Karoo, I can say, more common in the rock units that have been reconstructed as having formed in semi-arid, arid conditions.
That's fascinating. Morris added that the lack of bones is surprising, not present in the, I think, channel, the stratigraphy or SSTS. Are they just dissolved by groundwater?
Yes, I think that is, it's a taphonomic filter that we're seeing. Given the abundance of plants and decaying plants, because clearly that had to happen. I mean, we have not many, but we have even coal seams preserved in the Molteno Formation that must have changed the uh, geochemistry of the diagenetic environment. So I would imagine those bone fossils must have been dissolved. It is a project that we would like to investigate further. I have a postdoc researcher who is willing to take this question up and investigate it further, but it's certainly something that at this stage we only have vague ideas as an answers for. We haven't investigated this in detail.
Okay. Well, he goes on to add that in desert playas, rocks, mud clacks can be moved by wind on a slimy, slippery mud surface. So, guess that's something you could also look into. We have a question from Jim Hickey from Texas, US. So Jim says, very interesting talk. An early slide showed the CPE as an alternation between semi-arid and humid conditions. Is there evidence of this alternation in the sedimentology or paleontological features of the Molteno Formation?
Thank you. I think we are right on that slide now. Um, no, the answer to the question is no. To date, we don't have either sedimentary record in the Molteno suggesting that we have fluctuation between semi-arid to humid conditions. It's more like humid, but that can also be um, a, an well, what we're seeing could be linked to the fact that remember the Carnian is 10 million years in duration, so that's a long, long time. It's like going back from now all the way into the late Miocene, right? So it's a long period of time, and for this huge amount of time, the full thickness of the Molteno Formation, it's nowhere more than about 500 meters. So we have very little sediment preserved from that 10 million years. In other words, we have a very strongly punctuated rock record. We say it's fairly continuous, but everything is relative compared to other parts of the planet. This is a fairly continuous continental rock record for the Carnian, but that's not to say that is not riddled by many, many unconformities, meaning we have less record than time being represented by these rocks. So it could be that we didn't capture in our rock record those more semi-arid episodes, especially in this continental setting. We don't have deep lakes. The mudstones that have been investigated, none of them show deep permanent lakes. They mostly shallow water bodies, swamps, marshes, and so on.
Mm.
So yes, the problem there is, I think, the record is too coarse for us to be able to show fluctuations in our
Mm.
case.
All right. Well, we have a very last one. That's if we don't get any more from Fiona. Fiona says, if you're not fed up with questions,
No,
has
never.
anyone has anyone done any palynological investigations to complement large-scale botanical evidence?
Yes, there were attempts. The Andersons worked on this, and also with colleagues. They are macroflora specialists. Um, um, we also had recently researchers who have worked on this, but apparently I'm not sure if it's a bias on the paleobotanist side, because we really have so many of these beautifully preserved macro plants. But I can't recall a single recent study. I know that it was part of a PhD, but a dedicated article, dedicated um, output on this topic, I'm not aware of. So the field is wide open there, I would say.
Okay, okay. I guess that's the end of our questions. We would want to thank you again, Ameshe, for presenting today on Set Online. We also want to thank everyone who made time for today's presentation. We appreciate your time and we appreciate you being on this presentation. Thank you very much once again, Ameshe.